So this is a section from chapter 20, which is covered in Chem 1B, but we need to cover this because this topic is on the course outline of record for Chem 1A. And the topic here is balancing redox reactions. We have just talked about this. These are the slides for Chem 1B, and so I have to review that for people. We've got that. Well, the new stuff here is when we balance a redox reaction, not only does the mass have to balance, like the number of calcium atoms on each side have to be the same, but we also have to have the total charge be the same. It doesn't have to be 0, but if the reactant side is +2, then the product side has to be +2. Because if they're not the same, that means that electrons were created or destroyed, and that can't happen. So the way we're going to do this is called the half reaction method. We're going to break the equation into 2 half reactions, balance each of those reactions separately, and then put them back together. So your book lists this as a first step, and yeah, that would be ideal. You actually can balance it without assigning any oxidation states. Okay, so I'm just going to skip that. And we're about that in 1B. So we're going to separate the overall reaction into 2 half reactions. One will be oxidation, one will be reduction. You don't actually have to identify them. We're going to balance each of those half reactions for mass. We're going to do everything except hydrogen and oxygen. And then we're going to balance oxygen by adding H2O to whichever side we need it. And we're going to balance hydrogen by adding hydrogen ions. And we are not bringing new things into this reaction. These are in aqueous solution, in aqueous acidic solution. So they are literally swimming in water molecules, and it's acidic, so there's lots of hydrogen ions as well. So some of those things from the solvent are actually going to come in and be part of our reaction. Then we balance each half reaction with respect to charge, so the charge of products and reactants is equal, and we're going to do that by adding in electrons. So one of these reactions is going to be losing electrons, and one is going to be gaining electrons. After we've got that straightened out, we want to make sure that the number of electrons being lost is equal to the number of electrons being gained, and then we can add the 2 equations together and cancel out the electrons. And then, of course, you should always double check. So let's do a couple of examples. So here I have sort of a short version of the instructions, right? Balance the redox reaction in acidic solution. And again, I'm skipping step number 1. So we're going to make 2 half reactions. So here I have a reactant H+, and I need to pick which of the products is most like H+. This part is pretty easy, right? It's the H2, right? So those 2 go together in 1 half reaction, and the chromium things go in the other one. So I've got H+, aqueous, is somehow going to turn into H2 gas. And chromium solid is going to turn into chromium ions. 2 half reactions. Balance for mass. Okay, on this one I have 2 hydrogens on one side. I can fix this by putting a coefficient of 2 in front of the H+. This is a very simple example. In the second half reaction, I have 1 chromium and 1 chromium. It's already balanced for mass. Now we balance for charge. In this half reaction, I have a total of +2 on this side and 0 on the other. The charges have to be the same, and I'm going to fix it by adding electrons. If I add electrons to this side's going to be negative, and that side's going to be positive, and that's making it worse. So I'm going to add my electrons to the products for this one. Because if I have 2 electrons in here and 2 hydrogen ions, the total charge on that side is 0, And the total charge on the product side is 0 also. Reduction is gain of electrons. H plus is being reduced, it's gaining electrons. So the other one is going to have the electrons on the other side. Here we have 0 on the left and plus 2 on the right. So if I put 2 electrons over here, I get a total charge of 0 and a total charge of 0. Okay? Then we want to make sure that the number of electrons lost and gained is the same number. This time it is. We don't have to do anything. The next example will be a little messier. So those are equal, so now we can just add these two equations together. The electrons are always going to cancel out because we're setting it up that way. So 2 electrons and 2 electrons, those are going to cancel out. And then we'll just copy down what's left. We've got 2H plus aqueous plus Cr solid, making H2 gas, and Cr2 plus aqueous.
So, like, how would you know that when you, like, bounce a charge, I guess, you would have to take it apart yourself and double check that they're balanced? Is that smooth or something?
Well, if we look at our original equation, this side is +1 and that side's +2. They're not the same.
So just obviously, when we get down to our final product, we just kind of compare the first one to the bottom and make sure that we balance it out. I'm just saying, like,
Yeah. So the verifying
or the electron solution.
the verifying step would be I'm checking my mass: 2 hydrogens, 2 hydrogens, 1 chromium, 1 chromium. Look at the total charge here: +2. Total charge here, +2. It's a match. We're good.
So we don't need to write 2E at all, or any of them.
No, these guys are not going to show up in here because those electrons went directly from one thing to another thing, and they're not just like out there floating around. Maybe like, a Venmo thing. It just went boop, instant, right? So you can't see it. It happened though. Well, let's do another example. Do I just have one of these? I'm going to do this one because I did the other one yesterday. So balance the redox reaction in acidic solution. First thing we need to do is make 2 half reactions. So let's look at the first reactant. It's copper. And which product matches up with that? Cu2 plus. Right? So that's one. We've got copper solid going to Cu2 plus, aqueous. We need to have all those state symbols in the final balanced equation, but if you want to leave them out in the middle, that's okay. And so then the other one will be nitrate going to NO2 gas. 2 half reactions. Now we balance for mass, the atoms, right? So here, 1 copper, 1 copper. It's good. Here we've got 1 nitrogen and 1 nitrogen. We have 3 oxygens and 2 oxygens. You cannot balance that by inspection because when you change the oxygens, you change the nitrogens. And you're just going to go back and forth and it's never going to work. So I balance the nitrogens, and now I'm going to balance oxygen by using water because all of this is happening in water. It's not like we're throwing in some extra reactants. Apparently the train finally is moving. Imagine what the traffic's like out there. It's been like a long time. So I need another oxygen on this side. So I'm going to write H2O. So now I have 2 oxygens plus 1, total of 3 on that side. Now I created a new problem with hydrogens. We're going to balance the hydrogens by adding hydrogen ions, and they're not going to mess anything else up. So here I have one water molecule with two hydrogens, so I'm going to add two hydrogen ions to the other side. So two hydrogens, one nitrogen, three oxygens, mass balanced. Now I balance charge.
So could we always add H2O?
If you
Or is
need,
there a
if you
certain-
need to add oxygen, if you need to balance oxygen, you add water every time. And then you balance the hydrogens with a hydrogen ion. So, to balance the charge with electrons, if I put two electrons on this side, on the product side, then I get zero charge on each side. Remember, I'm not going for zero necessarily, I'm going for equal, balanced. They might both be +2, that's fine. Down here, I have +2 and -1. So that's a total of +1, right? Use your calculator if you need to, it's okay. And then over here, I've got 0 and 0. Well, the electrons on the product side over there are a big clue that I'm going to be adding electrons on the left side here, on the reactant side. And so if I add one electron, now I'm going to end up with 0. Okay? So I made half reactions, I balanced for mass, I balanced for charge. Now I'm going to make sure that the number of electrons is the same. I have 2 electrons here and only 1 electron over here. So I need to multiply everything in this equation by 2. We balanced it, and if we double everything, it will still be balanced. So this is going to be 2 electrons and 4 hydrogens and 2 nitrate ions and 2 NO2 molecules and 2 H2O molecules. And now I'm going to add them together. And my electrons cancel out. And I'm going to copy down what's left. Got solid copper plus 4 hydrogen ions plus 2 nitrate ions. It's going to make Cu2 plus 2 NO2 plus 2 H2O liquid. And then I want to look at that and make sure, because sometimes we'll have water on both sides, and then we need to simplify that and take the extra out. But this one we don't. It's balanced. Yes?
I don't understand why we did 4 of the 2 nitrogens. Did 4 of
That's a
them.
good question. Why did we do 4 here? In the purple, it was balanced with just 2 hydrogens there. But when I add these together, I want the 2 electrons that are lost to match the electrons that are gained over here. Because copper is losing electrons, so it's being oxidized. So this copper is losing 2 electrons, and whatever it is, it's actually the nitrogen, whatever it is down here that's being reduced is gaining 2 electrons. And so that's why I had to multiply all of these by 2.
Because of the 2 electrons?
Because of the 2 electrons up here. I need to make the electrons being lost and the electrons being gained be the same number of electrons.
What if it was 3 electrons lost? Would you multiply all the rest of the side by 3?
Yeah, if this was 3 and this was 1, I'd multiply the bottom one by 3. If this was 3 and that was 2, then we'd go for 6. And I multiply the top by 3 and the bottom by 2. So if you're familiar with math terms, I think they call that the least common multiple.
So only the top, so if you said they were different, the top would be multiplied by whatever electrons gained or lost, and then the second half would be
you can multiply the top and bottom equations by different numbers. In fact, they have to be different numbers. Otherwise, what's the point in doing it, right? Because that won't change the electrons if you do them the same, right? So it's going to be different. This time we just multiplied one of them. Sometimes you have to multiply both. So that was acidic solution. There's one extra step if it's a basic solution. The mass balancing, we're going to do everything but hydrogen and oxygen. We balance oxygen by adding water. We balance hydrogen by adding H+. This is the same. Here's the one extra step. A basic solution does not have hydrogen ions floating around. It has hydroxide ions floating around. So we're going to add hydroxide ions to both sides to neutralize the hydrogen ions. And
would it replace the H, or the H will still be there, and it would just add the OH?
the H+ will still be there,
And then we add the
but we'll add the OH. So let's say, like we had 2 hydrogen ions before we multiplied. So if that's what we were doing, what we would need to do is we would have to add 2 hydroxide ions to both sides. We got it all balanced with mass and charge. We don't want to mess that up. So if we add the same number of hydroxide ions to both sides, it's still balanced. But what we've done here, what does hydrogen ion and hydroxide ion make? H2O. So those are going to neutralize each other, and that's going to be 2 water molecules. I'm going to do the second example here, because I did the first example last night. So if you want to see the first example, you can watch the Tuesday-Thursday video. Okay, so notice this one says in basic solution. So this is like the harder kind because there's this extra step. First thing is to make 2 half reactions. So here I have ClO, and that must pair up with the Cl, right? And then this chromium compound or ion is going to go with this chromium ion. So, yeah, don't do that. So I've got my hypochlorite ion, and I have chloride ion, and then I have CrOH4 minus, and that's going to make chromate ion. 2 half reactions. Balanced for mass. 1 chlorine, 1 chlorine. There's 1 oxygen here. There are no oxygens. So how do I balance the oxygen? Adding water. Okay, so I'm going to add a water molecule over here. So now I have 1 oxygen on each side. I created a problem with the hydrogens. So now I'm going to fix the hydrogens by adding 2 hydrogen ions over there. So I've got 2 hydrogens and 2 hydrogens, 1 oxygen, 1 oxygen, 1 chlorine, 1 chlorine, mass balanced. But this is basic solution. So I'm going to look at how many hydrogen ions do I have. I'm going to add the same number of hydroxide ions, but I'm going to add the same to both sides. So I'm going to add 2 hydroxide ions to that side and 2 hydroxide ions to the other side. Hydrogen ions and hydroxide ions will neutralize each other and form water. So I'm going to, I guess you could say, simplify that. Those guys are going to react with each other, and that's going to be 2H2O. It is still balanced for mass. I have 4 hydrogens here, and I have 4 hydrogens there. I have 1 oxygen, 2 oxygens, and I have wait a minute, I have 2 and 1 is 3, and then I have 3 over there. It's still balanced for mass. What else could I do? Could I kind of simplify that some more? I've got 2 water molecules here, and I've got 1 water molecule there. What if I subtract a water molecule from both sides? Well, that didn't work. There's layers in here that are just kind of messy sometimes. But I think there. And you might ask, well, why can't we just balance it with hydroxides to start with? Because it gets ugly really fast. Question?
How are you able to subtract water molecule?
So I had 2 water molecules in the reactants and 1 water molecule in the product. That means that only one of those water molecules got used in the reaction and the other one is just left sitting there. And so I can subtract 1 from each side. Because it wasn't doing anything. Kind of like a spectator.
Okay. We can get rid of the spectator ions,
Mm-hmm.
but it doesn't mean it didn't happen, like the mass didn't disappear in the reaction.
No. And the thing to remember about writing chemical equations is this is a thing we've decided to do on paper, right? What we're doing on the paper or the screen does not affect what's actually happening in the solution. This is a technique we've learned or come up with to describe what's happening in the solution. Yeah. Okay, so we need to balance this bottom one for mass. I've got chromium, 4 oxygens, 4 oxygens. This side has 4 hydrogens. So I'm going to add 4 hydrogen ions to the other side. And I have mass balance. But it's a basic solution. So to the 4 hydrogen ions, I need to add 4 hydroxide ions. And if I do that on one side, I need to do it on the other side so it's still balanced. And then I can say to myself, well, 4 hydrogen ions and 4 hydroxide ions, those are going to neutralize each other and become 4 water molecules. There's always a couple of students in a class that really enjoy this. It's like a logic puzzle to them, and they'll get into it on the board and argue about it and stuff. And the rest of you are just like, oh my goodness. You can get an A in the class if you do not learn how to do this. Okay, but give it a shot. Try the homework, and then when you need this later, you're like, oh, I remember hearing about that. And for a lot of things, that's good enough, actually. So we need to balance this for charge. So on the left, I have a -1 charge, and on the right, I have -3. And again, you might need to write some stuff down and use your calculator. Adding up the little negatives can be kind of confusing. I have -3 over here and -1, so I'm going to have 2 electrons on that side.
When you say -3, are you including the 2 from the...
So I have hydroxide. I have 2 hydroxides.
Oh.
They're each -1.
Oh, okay.
Yeah. So down here I have -4 from these guys and -1. So that's a total of -5. And over here I have -2. So to make that into -5, I'm going to add 3 electrons. So now we need to make sure that the number of electrons are equal. Because otherwise, this is like a transaction where one person is paying $3 and the other person is getting $2. And what happened to that dollar? It doesn't work that way, right? So we can't have somebody losing 3 electrons and then the other person only gaining 2 electrons, because that means an electron went missing, and that can't happen. So the least common multiple for 2 and 3 is 6. So if I multiply, yeah, well, that's scary. If I multiply the top by 3 and the bottom equation by 2, I'll end up with 6 electrons for each. I highly encourage you to write this here, because I know from experience that it's really confusing if you don't. So I'm going to go through and I'm going to multiply all my coefficients. In the top, I'm multiplying by 3. So this becomes 6, and this is 3, and that's 3, and this is 3, and this one becomes 6. And then the bottom, I'm multiplying by 2. 2 times 4 is 8. That one's 2, and this one's 2, and this one's 8, and this one's 6. So now I can add these together. The 6 electrons that are lost by one are gained by the other. No electrons were lost or invented out of nowhere. And then I'm going to copy down everything else. So 3H2O plus 3ClO plus 8 hydroxide plus 2 CrOH4 minus. It's going to make 3 chlorides plus 6 hydroxides plus 2 chromates plus 8 water molecules. I've got 3 water molecules on this side and 8 on this side. And so I can subtract 3 water molecules from both sides. So subtracting 3 molecules from both sides, and these 3 go away. And my 8 becomes a 5. I subtracted 3 water molecules. It's still balanced because I did the same thing to both sides. What else is showing up on both sides? Hydroxide. I've got 6 of them here and 8 of them there. So I could subtract 6 from both sides. Any questions?
Do we have any practice problems on this in our worksheet?
I'm not sure if there are any practice problems in the worksheet. There are in the homework.